Okay, so this is review number 1 for the next test, which I believe is test number 8 for integrated 3. Okay, so before I start, I have circled a few problems that I want to do here in your review that you have already received. What I will say before I start is every time I start a new problem, what I suggest you guys do, because I want to make this video shorter than usual, what I suggest you guys do is every time I start a new problem, you try it on your own and pause it right away before you actually see me work it out. Okay, I think that would work out better for you guys and also for me, so I don't have to make a 50-minute video and I could actually get through all of the problems. So you guys have the ability to just pause it right away. Try it on your own first and then watch me do it and see where you messed up or see if you actually did it right. Okay, so let's get started. I'm starting with number 3. It says the balance B in dollars after T years of an investment that earns interest compounded annually is given by this function. To the nearest hundredth of a percent, what is the monthly interest rate for the investment? So right here is the clue, compounded annually. This investment is compounded annually, which means that we use this formula, which is in your notes. That's the formula that we use for anything that is compounded annually. Okay, so if I compare this formula that I just wrote here with what they have given me, I can easily see that P is 1500. That's not what they're asking me for, though. The question is, what is the monthly interest rate? Right? What is the monthly interest rate for the investment? Okay, keyword here is monthly. Not the annual interest rate, but the monthly interest rate. Okay, so that's a very important distinction, because R here stands for the annual interest rate, not the monthly interest rate. So we're going to figure out what R is in this case, and then we're going to figure out what the monthly rate is by dividing by 12. That's how simple it's going to be. Okay, so first let's solve for R. It's actually a real simple equation. What you do is you say, well, 1 plus R equals 1.045. Right? All I'm saying is this part right here is the inside of the parentheses here, so it's 1 plus R. So I solve that for R by simply subtracting 1. So if you subtract 1 from both sides, you're done. R is 0.045. But we don't want R, remember, I just said it, R always stands for the annual interest rate. This, whatever is in here, always stands for the annual interest rate. But they're not asking for the annual interest rate, they're asking for the monthly interest rate. So what I'm going to do now is divide that by 12. So divide it by 12 to find the monthly interest rate. So monthly is whatever 0.045 divided by 12 is. So at this point I need a calculator. And my calculator says 0.00375. Okay, now all I gotta do is just change that to percent form. It's not in percent form, right? It's in decimal form. So what I'm gonna do is I'm gonna move the decimal over twice. Once, twice. So my final result is 0.375. So the closest one I see here is A. Although it should actually say 0.38 because it should be rounded up, but that is the closest one we see. Okay, let's continue. Here's number 9. And like I said at the beginning, make sure you guys are trying this on your own first. So pause it right now, try it, then come back and see my work, okay? Here we go. Which is the logarithmic form of 2 to the 10th equals 1024? So if you recall, the rules of logarithms go like this. Okay, I'm going to write basically the formula or the definition that I showed you guys. B to the x equals y. That's just an exponential equation. In order to turn that into logarithmic form, what you do is you write log. You use the same base that you have here is now the base of your log right there. So base b. And then this is where it switches. The input and the output switches, right? Here the input is x, the output is y. Here the input is going to be y, the output is going to be x. Okay, so you're going to put y equals x. Log base b of y is equal to x. Those two are equivalent equations. They are the same equation, just written in different forms. Okay, so I'm going to use that to put this in logarithmic form. So it's going to be log. The base is the base of that exponential expression right there, which is 2. So log base 2 of 1024 equals 10. See how we switch the 1024 and the 10? The input switches with the output. They are inverse operations, right? So there you go. Log base 2 of 1024 is equal to 10. That means that the answer is B. That was easy. Okay, since that one was so easy, let's test ourselves with another one of the same kind, right? Very, very simply change that into logarithmic form. Here we go. It's going to be log. The base is going to be 3, right? Same base as this one. My input now is going to be 729, and my output is going to be 6. Therefore, it is A again. Log base 3 of 729 equals 6. Alright, let's keep going. We're on a roll here. I'm skipping all the way to number 16. So here we go. Which of these is equal to log base 9 of 2 plus log base 9 of 8? So what I'm going to do is put them together using this property right here that I'm about to write down. There's a property that says that if I have two logarithms with the same base, and I'm trying to add them, see those two logarithms? They have the same base b, but two different inputs, m and n. Then I can add them together simply by multiplying the inputs. Leave the base the same, but multiply m times n, right? You multiply them times each other. You can do that to put to add two logarithms together. So I'm going to use that property right here, because both of these have the same base, which is base 9. So it's going to be log base 9 of 2 times 8, right? I'm supposed to multiply these two numbers. So it's going to be 16. Log base 9 of 16. None of those solutions look like that, right? So what I'm going to do next is use the change of base formula to write it as log of 16 over log of 9. We practice that over and over again. You can change the base to whatever you want. In this case, I changed it to base 10, right? The common logarithm. Next, what I'm going to do, because none of those answers look like that one still, what I'm going to do is change the 16 to 4 squared. So it's going to be log of 4 squared over log of 3 squared. Right? And you might have seen that right away, but by looking at the answers, I noticed that none of them said 16 and 9, right? There's a couple of 9s, but no 16s. But I did notice that 16 and 9 were both perfect squares, so I changed them both to that form. Next, what I'm going to do is use the power property to move these 2's to the front, both of them, right? Each one moves to the front of their own logarithm. So it's going to be 2 log of 4 over 2 log of 3. And my final step is to cancel the 2's. So it's just log of 4 over log of 3, which is B. There's your final answer. Right, the next one is 18. It says, if there are initially 5,000 bacteria in a culture and the number of bacteria doubles each hour, the number n of bacteria after t hours can be found using this formula. So they gave us the formula. We don't have to come up with it on by ourselves. But it would have been easy to come up with. They gave us that the initial is 5,000, so that's 5,000. And this 2 comes from the fact that the bacteria doubles each hour, which means that the base is 2. It's being multiplied by 2 every hour. And T stands for hours, right? About how long will it take the culture to grow to 40,000 bacteria? All right, so let's solve this. What I'm going to do is use the formula that they gave me. Plug in 40,000, not for T, right? This does not stand for hours. It stands for the number of bacteria. So I'm going to plug it in right there. So it'll look like this. 40,000 equals 5,000 times 2 to the power of T. And that's what I'm about to solve. To solve this equation, the first thing I'm going to do is divide by 5,000, right? You want your power, the 2 to the T power, to be all by itself with nothing else around it. So when I divide by 5,000, that cancels. So on this side, it's just 2 to the T power. On the left side, it's 40,000 divided by 5,000. What I can do is cross out a few of those zeros, 3 zeros, 3 zeros. So really it's just 40 divided by 5, which is 8. Okay, and now to finish it, what I'm going to do is take a logarithm here. Okay, so I'm going to take log of both sides. Many of you guys probably see the answer already because these numbers are so simple and they're base 2. But I want to solve it using logarithms because that's what we're practicing in this unit. So I'm going to take the log base 10, the common log of both sides. And remember, I keep saying you guys have the option of which base to use. I'm using base 10, but you could use base 2, right? That might help you out. Or you could use base E if you want to. Use the natural log. Okay, either way, it's going to help you out. What I'm going to do next is move the t down using the power property. Right? So I'm going to have to erase some work here so that I can make it fit. Oh, you know what? I'm just going to move the page over. There you go. So I'm going to move the t down. So I end up with, I'm going to continue up here. Log of 8 equals t log of 2. Next, to isolate t, I'm going to divide by log of 2 on both sides. Those cancel, so it's just t. T equals log of 8 over log of 2. Okay, and at this point, I could use a calculator to find what log of 8 over log of 2 is. I'm not going to, though. I want to continue working without a calculator. So what I notice now is that log of 8 is 2 cubed. 8 is 2 cubed, right? So it's log of 2 cubed over log of 2. Next, I bring the 3 to the front using the power property again. So 3 log of 2 over log of 2 equals t. Log of 2 cancels log of 2, so t equals 3. And let's see which of these, well, none of them are right. Okay, so then let me double check all of my work because none of those answers, none of those solutions are 3. Let me see, I plugged in 40,000 for the number of culture that I want. I divided by 5,000, 40,000 divided by 5,000, just double check that. Yeah, that's 8, right? It's 40 divided by 5. So then I took 8 equals 2 to the power of t. Right at this point, I already saw the answer because I know 8 is 2 cubed. So 2 cubed equals 2 to the t power, so t equals 3. Yeah, our work is correct. If I check the answer key, it says that it's C. I guess it's close, but I don't know why they put 3.3 here. Okay, the correct answer is 3 hours. So, something wrong with the solutions here. Okay, 46 says, evaluate log base 4 of 1 over 16 by using mental math. Okay, now using mental math is going to be a little tough. So we're not truly going to use fully mental math, but we're going to solve it without a calculator is the point here. So I'm going to solve it without a calculator using my knowledge about logs and exponents as well. Okay, so I'm going to start by writing 1 over 16. And you guys think about this. This is correct. As 16 to the negative 1 power. Right? Yeah, reciprocal, right? 1 over 16, 16 to the negative 1 power. I'm going to continue by writing 16 as 4 squared. I could also write it as 2 to the 4th power, but I want 4 squared because the base of my log here is already 4. So 16 is 4 squared, so 4 squared to the negative 1 power, which basically means 4 to the negative 2 power. And at that point I'm done. Right? Because log base 4 of 4 is going to cancel out. This is basically negative 2, which always happens when you have the same base and the same input here. Right? Same base here, same base for this exponent here. Therefore, all that's left is negative 2. And the reason for that has to do with the power property. We can bring this down, and this is just 1. So it's just negative 2 times 1, which is negative 2. Your answer is negative 2. Okay, the next one I'm doing is 47. It says evaluate log base 9 of 243. If necessary, round your answer to the nearest tenth, it says. So I don't want to, well, I guess we're going to have to use a calculator because it says round your answer to the nearest tenth, right? So they're basically encouraging us to use a calculator. I'm going to try not to until it's absolutely necessary. So here we go. Log base 9 of 243. The first thing I'm going to do is write that 243 as a power of, what is 243 a power of 3? Let's check that. I think it's 3 to the 7th power, or maybe 6. Let's see. No, not 7 or 6, it's 5. 243 is 3 to the 5th power. You guys can double check that on your calculator. 3 to the 5th power is 243. So I'm going to use that fact. So I'm going to write this log as log base 9 of 3 to the 5th power. Okay. Next, what I'm going to do is, let's see, is it easier to bring the 5 up to the front? Yes, let's do that. I'm going to bring the 5 this way. So it's going to be 5 log base 9 of 3. I'm going to rewrite log base 9 of 3 as log of 3 over log of 9, right? Change of base formula. So it's 5 times log of 3 over log of 9. Okay. I also notice that 9 is 3 squared, so I'm going to rewrite that as well. So let's continue up here. It's 5 outside, and then inside log of 3 over log of 3 squared. Right, that's 9. Now I can take that 2 and bring it to the front. So now it's 5 times log of 3 over 2 log of 3. Whew, we're done. What happens with log of 3 and log of 3? They cancel, right? You divide the same number by itself, you get 1. So it's 5 times 1 over 2, right? When you cancel that numerator, you still have a 1 up there left over. So it's 5 times 1 over 2, which is 5 halves, which is approximately 2.5. It says round to the nearest tenth, right? So we're going to leave it as a decimal, 2.5. Yes, you could have done this with the calculator, right? At this point right here, right at the beginning, you could write that as log of 243 over log of 9. Okay. But that's kind of cheating, right? You want to be able to manipulate them yourself without having to count on the calculator every single time. All right, I am going to continue with number 53. Now, I could solve this problem by breaking them down, both down to the same base. That is one way of doing it, but I want to solve it using logarithms. Okay, that's my whole idea here. That's my whole point. I want to solve it using logarithms. So here we go. I'm going to start by taking the log of both sides. And I'm going to use just the common log, base 10. Log of 32 to the power of 2x minus 1. Alright, so log of 4 to the power of 4x minus 1 equals log of 32 to the power of 2x minus 1. What I'm going to do now is bring this down to the front and bring this down to the front, right? Both of those are going to come down. So I'm going to get 4x minus 1. And I'm going to put it in parentheses because it's two terms. Times log of 4 equals 2x minus 1 times log of 32. Okay. Next, what I'm going to do is I'm going to try to isolate the x's by dividing by log of, what would be easier? Log of 4. Right. I'm going to divide by log of 4. Log of 4. That cancels. So it's 4x minus 1 equals 2x minus 1. I'm going to still leave it in parentheses. Times log of 32 over log of 4. And in order to save myself some time, I'm just going to go ahead and calculate that right now and write it as a decimal or as a whole number, depending on what my calculator tells me. Although I already know what it is. That's 2 to the 5th power and 2 squared. So it's 5 over 2. But just to double check, punch that into your calculator. Then my calculator says that that is 2.5, right? 5 over 2. So I'm going to continue up here. 4x minus 1 equals 2x minus 1 times 2.5. I'm going to distribute that 2.5. This is not 25, it's 2.5. So I get 4x minus 1 equals 2.5 times 2, that's 5x minus 2.5. And now all I have is just a simple linear equation that I can solve. I am going to subtract 4x here on both sides. That cancels, so it's minus 1 equals x minus 2.5. I'm going to add 2.5 on both sides. And so x equals 1.5, or 3 halves. That's your final answer. Okay, now I want to show you guys, on that same problem, I want to show you how you can solve it without the need of logarithms, right? Just using exponents, which was in Unit 13, which is still in this chapter, so it's useful to know it. So let me erase all this and solve it without having to use logarithms. And we're going to get the same answer, watch. And this one can be solved without logarithms because I do notice that 4 and 32 are the same base. They have the same base. Those are both powers of the same base, which is 2, right? So I can write 4 as 2 squared to the power of 4x minus 1. And I can write 32 as 2 to the 5th to the power of 2x minus 1. And then I can use the power of a power rule, which says that I can multiply this times these two. So it's going to be 2 to the power of 2 times 4x is 8x minus 2. On the right side is 2 to the power of 10x minus 5, right? Distribute the 5. And then I notice that the bases are the same, right? Base 2, base 2. So that must mean that the exponents are the same, right? If these two powers are equal to each other and their bases are equal to each other, then their exponents must be equal to each other. So I just said 8x minus 2 equals 10x minus 5. And then I subtract 8x. So I got negative 2 equals 2x minus 5. And I know I'm getting sloppy, but at this point you guys know how to solve a linear equation. Okay, I'm going to erase my answer here, but I know what it is, 1.5. It should be the exact same thing. Negative 2 equals 2x minus 5. What I'm going to do next is continue up here, is add 5 to both sides. So it's 3 equals 2x. And then I divide by 2, and there it is. 3 divided by 2 is 1.5. Same answer. And this method is actually faster than logarithms, right? The thing with this method, yes, we like it and it's useful and it's awesome and we don't have to be messing with logs. The thing with it is that it only works if I notice that they have the same base, right? If this was 33, all of a sudden this doesn't work. We have to use logarithms. All right, I'm continuing with 54. 4 to the power of x minus 4 equals 0.5 to the power of 5 minus 2x. Okay, I am going to start by, let's see, what should I do? I am going to, should I use logarithms? Yeah, I'm going to go for logarithms. Why not? We're still in that unit, right? I'm going to take the log of both sides as it is. There's a lot of things that I could do to make it maybe a little easier or simpler, but I don't want to lose you guys. I'm just going to take the log of both sides. 4 to the power of x minus 4 log 0.5 to the power of 5 minus 2x. I am going to bring down both of my exponents to the front of my logarithm. So it's going to be x minus 4 times log of 4. And notice that I'm using the common log, base 10, because I have a feeling that I'm going to need my calculator. Maybe not, but we'll see. Same thing here, I use base 10, right? You have to use the same base on both sides. Equals, in parentheses, 5 minus 2x times log of 0.5. Okay, so next I am going to divide by log of 0.5. I also could have chosen to divide by log of 4. Log, not just 0.5, but the log of 0.5. It's going to cancel on that side. On this side, what I'm going to do is I'm going to use my calculator to calculate what log of 4 divided by log of 0.5 is. I know what it is, and some of you guys might be able to tell. If log of 0.5 is 1/2, that means 2 to the negative 1. Right? Think about what I'm saying. I'm doing a little bit of mental math back here. This is 1/2, which is 2 to the negative 1 power. This is 2 squared. So if you just think about their exponents of each one of these, they both have the same base, which is 2 and 2. The exponent of this one is 2. The exponent of this one is negative 1. So when I do this division, I am going to get negative 2. But again, you can check that with your calculator. Punch in log of 4 divided by log of 0.5. You're going to get negative 2. So what I have now is x minus 4 times negative 2, which I'm going to put in the front. I could put it in the other side, but I'm going to leave it in the front. And on that side, it's just 5 minus 2x. I'm going to distribute the negative 2, get negative 2x plus 8. And now to solve this, I'm going to add 2x to both sides, and then I just realized something, right? Maybe some of you guys saw it too. When I add 2x to both sides, what happens to the x's? They both go away. So you're left with 8 equals 5, which is not a true statement, which means that this equation has no solution. And sometimes that happens. That's okay. This equation has no solution because the x's got eliminated and we ended up with 8 equals 5, which is not true, right? And this is a concept from integrated 1 or algebra 1, right? If you end up with a statement that is true, no x's left, no solution. With that is false. If you end up with a statement that is true, for example, if this was 8 equals 8, we would say that this equation has infinitely many solutions. Alright, I'm continuing with 55. It says express the log base 4 of 18 minus 1/2 the log base 4 of 36 plus 2 times the log base 4 of 3 as a single logarithm. So this is where we practice those properties of logarithms. I need to add these two logs that have the same base. So that's the product property. Once I do that, I can subtract this one minus this one. That's the quotient property. So watch. This is what I'm saying. I'm going to write down the properties real quick. When I have a logarithm, two logarithms with the same base, I can add them by keeping the base and multiplying their inputs. So it's going to be mn, m times n. Or I can subtract them. This is another property, but it's very closely related, right? It's the same idea. I can subtract them by keeping the base, but instead of multiplying them like up here, I have to divide them. M over. Those are the two properties that I need to use. Okay, so let's do it. Let me erase this so that I can work. Now the interesting thing about the property though is that if there's a coefficient in front of the logarithms, then all of a sudden it's not going to work as well. So see this 1/2 here and the 2 here, they're in the way. We need to get rid of them. So what I'm going to do is, this is counterintuitive to some of you guys, we usually take the exponent and bring it down. I'm going to take it and put it up there for both of them. So this is what I have. Log base 4 of 18. I'm leaving that one alone for now. I'm just worried about this one right here. It's going to be log base 4 of 36 to the 1/2 power. I need more space. Plus log base 4 of 3 squared. See that? This 1/2 came from here. It moved up. The 2 also came from here. It moved up. I'm going to simplify both of these. I know what 36 to the 1/2 power is. You should too. That's a rational exponent. 36 to the 1/2 power really means square root of 36, right? That was the last unit that we covered. So the square root of 36 is 6. This is just log base 4 of 6. Let me rewrite that again. The first one, again, I'm leaving it alone for now. I'm not touching it at all. I'm just worried about the stuff in the parentheses. Log base 4 of 6 plus log base 4 of 9, because it's 3 squared. Right, 3 squared. Much simpler now. Now I can use that property where I can add them. They have the same base, so I can add them simply by multiplying these two numbers. So it's going to be 9 times 6, right, 54. So let's keep going. Log base 4 of 18, I haven't touched that one yet, minus log base 4 of 54. Where did the 54 come from? 6 times 9, right? Same base, keep the base, multiply these two inputs. And now here, now that I've pretty much cleaned up the inside of the parentheses, I can subtract them using the quotient property. So it's the same as the product property. If you add the two logs, you multiply these two numbers. If you subtract the two logs, you divide these two numbers. So it's going to be log base 4 of 18 over 54, which I'm going to simplify. Keep going. Log base 4, 18 over 54. Both of those can be divided by 18, so it's 1 over 3. Yeah. That's it. That is as clean as you're going to get it, right? It says express it as a single logarithm. We expressed it as the simplest possible logarithm there. Okay, I'm going to do a few more of those same type of problems. So the next one is 56. Same idea. Two logarithms with the same base. In this case, I'm subtracting them, so I'm using the quotient property. It says log, red, okay, we'll continue with red. Base 2 of 64 minus log base 2 of 4, I'm supposed to divide these two numbers. So it's going to be 64 divided by 4. And actually, 4 goes into 64 perfectly. So it's log base 2 of, what is 64 divided by 4? 16. It says simplify if possible. It is possible. We're going to simplify this. How, you ask? I notice that the base is 2. I also notice that 16 is a power of 2. So I'm going to use that. Log base 2 of 2 to the, what is 16? 4th. And look how neatly that worked out. I'm going to take that 4, bring it down, and this cancels, right? That's just 1. So it's 4. So we did express it as a single logarithm right here, but then it says to simplify, so it's simplified down to this. That's your final answer. Okay, so moving on to 58. Express log base 3 of 27 to the negative 3 power as a product. Simplify if possible. Okay, so what do they mean by product? It just means that move this down so that it's something times something, right? So that's what we're going to do. We're going to simplify this basically. I'm going to bring the negative 3 down. So it's negative 3 times log base 3 of 27. Then I notice that 27 is a power of 3. That's something that you guys should start looking out for, right? The base is 3, and this is a power of 3. So I can rewrite it as negative 3 log base 3 of 3 cubed. That's a lot of 3's. Right, 27 is 3 to the 3rd power. 3 times 3 times 3. And then I notice that log base 3 of 3 is going to cancel out, leaving me with just 3. Right? Or you can think of this, I'm going to bring this 3 down over here, so it's going to multiply times that one. Either way, this cancels. Right? The log base 3 of 3 is going to be just 1. So it's negative 3 times 3. Negative 9. And you're done. You could have, right from the beginning, let me just write it again. It's actually real simple, so I have time to do it. Log base 3 of 3 to the 3rd to the negative 3. Dang, that's a lot of 3's now. Notice what I did. It's the same problem as the original, except I wrote 27 as 3 cubed. Right? The 3 of the base is still there, and the exponent of negative 3 is still there. Which turns into log base 3 of 3 to the negative 9th power, right? Because you're supposed to multiply this 3 with that negative 3. And then there's your answer again. I bring down the negative 9, bring it to the front. So it's just negative 9 times log base 3 of 3, which cancels, so it's just negative 9. I get the same answer either way. Okay, next I have 60. Solve 3 to the power of x plus 15 equals 81 to the power of x. Now I can go the logarithmic methods, right, which is what I've been using in all of the examples so far, which says that I'm going to take the log of both sides. But I'm not going to on this one because I want you guys to get used to also to the other method, which is keeping the same base, right? You should notice here that 3 and 81 are both powers of the same base. This is 3 to the 1 power, right? And this is 3 to the 4th power, right? 3 times 3 times 3 times 3. This is 3 to the 4th power. So I'm going to write them both as the same base, and that's going to allow me to solve it really fast. Now, 3 is already base 3, right? There's really not much to do there. But 81 is 3 to the 4th to the x, which is 3 to the 4x. And now that they both have the same base, that means that their exponents are going to be the same. X plus 15 and 4x are equal to each other. So that's what I have. And now it's a simple linear equation. Solve it by subtracting x. I got 15 equals 3x. I divide by 3. And look how fast and easy that was. What if you don't notice that 81 is a power of 3? Then are you stuck? No, you still have logarithms, right? Take the log of both sides. Right? Take the log of that side. Take the log of that side. Use the power rule to bring the exponents down, and then solve that way by dividing using a calculator. You'll still get the same answer. But it's much faster, as you can see, if you do notice that 81 and 3 are powers of the same base. Okay, I believe this is the last one in this review. I probably will post another one, I don't know yet. But this one should be able to hold you guys over until I do come around to posting another one. I need to make one where I do talk about graphing, right? There's no graphing in this review, so I gotta make sure I do at least one of those. But this is the last one in this review. Here we go. Solve log base 5 of x to the 10th minus log base 5 of x to the 6th equals 21. Okay, I'm gonna use the let's see, what should I use? There's a lot of different things you could use here. Okay, you could bring the 10 and the 6 down and then subtract them since they are exactly the same. Log base 5 of x, log base 5 of x. You could say 10 minus 6. But what I'm going to do is I'm going to use the quotient property, which says that if I subtract two logarithms with the same base, I can put them together by dividing these two things, right? I'm going to write that property again. I've been writing it over and over again. Log base b of m minus log base b of n equals log base b of m over n, right? If you subtract two logarithms with the same base, that's the same thing as keeping the same base but dividing the two numbers. So that's what I'm going to use. So it's going to be log, in this case, base 5 of x to the 10th over x to the 6th equals 21. Right? All I did was put this one over that one. Now, x to the 10th over x to the 6th, remember your old properties of powers. X to the 10th divided by x to the 6th is just x to the 4th. So this is log base 5 of x to the 4th. There you go, I'm almost there. I'm going to bring the 4 down. 4 log base 5 of x equals 21. I'm going to divide by 4. So I'm going to continue over here. Let me scroll over. I got log base 5 of x equals 21 divided by 4, which is 5.25. I'm going to write it as a decimal so that I don't have to be dealing with fractions. And now all I have to do to finish it is to turn this logarithmic form into exponential form, right? At this point you might think, I'm stuck, I don't know what to do to isolate the x. And this is a very common mistake which makes no sense. Don't do this. People do this. I'm going to divide by log base 5. So I can cancel those and leave x. That doesn't work, guys. X is the input of this logarithm. You can't really just take it out that way, okay? So people end up messing up and saying it's 5.25 divided by log of 5, which is not even the correct way. So no, don't do that. Let me erase all this junk that I just made here. What I'm going to do is change this to exponential form. So if you notice, the base of this logarithm is 5, so that's my base of my exponent, 5, to the power of 5.25 is equal to x. And at that point, it's really just a calculator. I can punch that into a calculator to get my final answer. So your final answer is going to be, according to the calculator, 4672.9. Let's make it 73. And you're done. Okay, that was the last example. Go ahead and watch the video again and review for the quiz tomorrow and the test next week.